Welcome back, Agent. Let's discuss encryption and hashing. The intelligence from the last mission from the images led to an encrypted message. Python can be used to perform cryptographic encryption. To understand encryption in general, we first need to understand hashing. A hash function is any function that is used to map data of an arbitrary size to data of a fixed size. Let's look at a very simple example where the hash function is performing the mod operator with 2 on the length of a string. So on the left-hand side, we have just any arbitrary string. So the string can be as large as you want or as small as you want. Here we have just a few small examples. And then we pass it through a hash function. In this case, the hash function is just take the length of the string and then mod 2 and get the result. And that basically just checks, is there an even number of characters or an odd number of characters in this string? And no matter how big the string is that you pass to this hash function, you're always going to get one of two results, either a 1 or a 0, where 0 indicates that there was an even number of characters in the string, and 1 indicates that there was an odd number of characters. So now we can take an arbitrary string of any size, pass it through this hash function, and get back a fixed size result. Now notice something important here. We cannot go backwards. This is a one-way hash function, because I can't just give you a result of 1 or 0 and the hash function itself, and then expect you to figure out what the arbitrary string was on the other end. Now, a one-way cryptographic hash function is more complex than what we just saw because it must be able to provide a unique hash for any information passed to it. Previously, we saw here that we have repeated hashes, 1s and 0s, but a cryptographic hash has to be unique for any arbitrary data that is passed to it. So that's quite harder of a problem to solve. And the ideal hash function actually has 3 main properties, and this is for cryptographic hash functions. The first property it should have is that it should be extremely easy to calculate the hash for any given data. It can't take forever, otherwise it's basically a useless hash function because you're going to be waiting all day for it to compute the hash. So the first one is it has to be quite fast. The second one is that it has to be extremely computationally difficult to calculate the alphanumeric text that has a given hash. That is, it must be really hard to go from the unique hash, knowing the hash function, to go back to the arbitrary data. And then the third one is that it has to be extremely unlikely that 2 slightly different messages will have the same hash. These 3 components are the main properties that a cryptographic hash function must have. Now there are many cryptographic hash functions that exist, MD5, SHA, Blake, there's tons of them, and many older hash functions have actually been deemed insecure due to discoveries of what are known as collision attacks, where different arbitrary data inputs are discovered to have the same hashed output. Remember, one of the key components of a cryptographic hash function is that any arbitrary piece of data that you pass into it has to have its own unique hash. The SHA, or Secure Hash Algorithm, is a set of standard hash functions developed by the NSA. These hash functions are essentially just mathematical formulas to follow, and they're open to the public. And in fact, the latest secure hash algorithms are discovered through open competitions. Now, the Wikipedia on cryptographic hash functions is a great resource for learning about the latest developments, as well as the various algorithms available. And we'll be discussing the various algorithms available in the cryptographic libraries we use later on. So now that we understand cryptographic hashing, that is just a one-way hash of grabbing arbitrary data, passing it through the hash function, and getting some unique hash out of it, we're going to now discuss encryption and decryption. Encryption differs from hashing because the message needs to be able to be decrypted. That is, we have to actually go backwards. To decrypt an encrypted message, usually a key is required. In cryptography, a cipher is an algorithm for performing encryption and decryption. And typically, ciphers require a key. This key is then only known by 2 parties, the sender and receiver. And this actually allows for the message to be beamed publicly, but only readable by its intended recipient. So that would look something like this. We have some original message, let's say hello, and we create some cryptographic cipher with a particular key, and that will end up producing an encrypted message. So we can send that encrypted message through public means because it doesn't really matter to us if anyone sees that encrypted message because they can only decrypt it if they know the key. So keep in mind, this all depends on keeping that private key secret. And there's other ideas that expand from this, such as private public key encryption, that actually solve some of these problems of allowing yourself to expose a public version of the key and then holding a private key yourself. But for our purposes, we just need to have the idea that we have some original message, we create a cipher using some private key, we have an encrypted message, and then if someone wants to decrypt that message, that is, go back to the original message, they just need to know the key for the cipher. To explore all of these concepts in Python, we have to install the cryptography library. To do so, go to your command line and type out pip install cryptography and install the cryptography library. Up next, we're going to explore these concepts in code in Python. We'll see you there, agent.